So now that we know the importance of properly citing sources, we need to understand the best way to select our sources. Because not all sources are made equal. If you want to find out about astronomy for a physics research paper, you don't want to go to YouTube and find some flat earther video, because these people do not understand astronomy or gravity or geology or how GPS systems work or how communication satellites work or how the horizon works or why the sky is blue, which also requires a spherical Earth. But you can find books written about certain topics. You want to make sure that they're up to date. So how can we do this? Well, what a lot of students typically do is they go to the beautiful and convenient Wikipedia and just start citing it. You do not want to use Wikipedia as the source. Not because the information is inaccurate. It's usually pretty good, but because anyone can edit it, it does get errors creeping in. This is why they have had to lock down certain articles, so only certain hand-chosen experts can update pages on things like vaccines, or, believe it or not, the types of kryptonite is handled by comic editor Mark Waid. But the main reason we don't want to use Wikipedia is because you want to go back to the original source. So why is that important? Well, you might remember in elementary school, there'd be a game called Telephone. So they'd have a bunch of kids usually sit in a circle, and someone would come up with a message and they'd whisper it in their neighbor's ear. Right? So say the first one would say hello, they'd whisper, it would pass and pass and pass as it's whispered, and then the last person would say what they heard by the time it got to them, and that message doesn't match what was originally said. This happens in academic circles because people often will summarize or rephrase things rather than directly quoting them. Sometimes they just misunderstand, misinterpret, or mishear. So you always want to go to the original source. And that's not Wikipedia or any other encyclopedia. So you get some researcher, they're in a lab or, they're doing research in a museum. They figure something out and have that eureka moment. Yay! Well, then they go publish in some kind of journal. And then someone else reads that journal and think, whoa, that's cool. And this someone else puts it on Wikipedia. Now, sometimes this is a discovery article and it hasn't been confirmed. There could have been a mistake in the procedure, so it may not be completely valid or up to date. Sometimes it's not, but the key is that the researcher who did the work in the first place didn't publish to Wikipedia. That researcher published to a peer-reviewed journal. That is the key. So Wikipedia is an effective starting point. You can go to Wikipedia and you can read what Wikipedia has to say, and you could find something relevant, and it'll have a little blue number in square brackets around it. That's the citation. You can click on that number. It jumps to the bottom of the Wikipedia page, and it brings you in a link back to the journal. So you can find something relevant on Wikipedia, but you don't want to quote Wikipedia directly. You want to follow Wikipedia to its sources. Sometimes when you do that, you'll get to the source and find out, oh, this has been redacted. If something has been redacted, then that means it has been proven untrue when they previously thought it was true, such as Andrew Wakefield's quote-unquote research into vaccines and their connection with autism. So you follow that back to the original source, and it's the source that you cite. and not the Wikipedia page. That is the key to having effective bibliographies. And I guarantee you, especially at the university, you will not be allowed to use Wikipedia as a source. You must follow it through and verify it right from the origin. And even if you don't use Wikipedia, you have to take a look at who's writing what. What are their credentials? So, for example, a personal pet peeve of mine. You may have seen Star Trek Discovery. There is a character on that show who's named after a real-life scientist, Paul Stamets. And Paul Stamets suggested a means of faster-than-light travel called a mycelial network. And that's what they incorporated in the show. So their spaceship doesn't travel faster than light like previous Star Treks did. It teleports and moves instantaneously to another part of the galaxy by using basically space fungus. And the marketers said, oh, this is fantastic. They named a character after him. For the first time, Star Trek has actual viable potential to talk about how to travel faster than light. Well, let's follow Paul Stamets. Is he a scientist? Yes, he does hold a BSc in forestry. And he may be self-taught with a lot of mushrooms. That's actually what he does his study in. If you read his books, you could find a bunch of them on Amazon. They're all about sort of the mystical healing powers or benefits of mushrooms to the ecology, which is a field that he would be considered an expert in. But there's nothing in his background that would suggest that he understands the laws of physics well enough to know whether these mushrooms can bypass the light speed limit and skip that speed of light, or that speed limit that is embedded in the universe for faster than light travel. So in this case, he was not a reliable resource. And yet, they built it into the show and advertised it as though it was. So, they did go back to the original source. Big green check for them. But the source was not a credible source in the field of study. Big red X. In a lot of the videos that you will see online that are opposed to things like vaccines or claiming that the earth is flat, they love to find people who hold PhDs, and they'll have them up there saying so-and-so PhD. Dig into them online, the PhDs that they have do not match the subject that they're talking about. Now, I don't have a PhD. I've got an MSc. It's in physics, which is why I don't pretend to be able to understand a lot of what's going on in biology and other things with vaccines. I can refute Andrew Wakefield's work based purely on his math, but not on the way he talks about the protein structures. You cannot claim an effect out of 1 in 110 patients when you only have 8 in your study. But I can make reasonable comments about things like the shape of the earth. So, always trace back to original sources. Always check to see that the source does seem to be reliable and educated and knowledgeable about the content that you were discussing. And then the third video in the series will be how to actually do the citation on the page, how to write the bibliography in an effective way.